Bet you weren't expecting that. Hello. Okay, I think you were expecting me to pop out from some part of the screen. Okay. All right, let's get on with it. Parameters. Parameters. What are parameters, or what are parametric equations, right? Well, I think I introduced it to you when I introduced the unit to you, but I'll do it again. Okay. You know how you've been dealing with always two variables at a time? But I know that some of you guys are thinking, well, we can add a Zemus chain, and that makes it 3D. But we're not talking about 3D. With looking at 2D graphs, like the one that's here, this very, very professionally sketched right here, I bet you I can tell you, like, not just that you'll know X's and Y's. Where is Y when X is this? That's what you can say from this, right? But what if I told you I can tell you which direction it's moving in? Whoa. Right now, you don't know if it's going this way or you don't know if it's going this way, right? But what if I could tell you exactly when this graph started and it ended, or if it's going this direction or this direction? We're going to do that today. That's called adding a parameter. The parameter would be like, I don't know, time. You have X and Y, like horizontal and vertical distance, but you add an extra parameter called time. And that's what we're going to show today. So definition of parametric curve, parametric equations, okay? The graph of the order pair XY, you know how to graph XY. Like, you know, every pair, you connect the pairs and you get a graph, right? But what if I told you that X, but if you think about it, right? If something travels horizontally and vertically and you can graph it like this, you know that you can graph this with time. Because with every time, because you can, I mean, if I sketch a mini one, right? I can go time and X. That means I could tell you at what minute, what second, what hour, horizontally where it was. But I can do that same thing with time and Y value, right? At what time was the height something, you know, whatever the height was, or whatever the Y value was, whatever the vertical was, right? So wait, if I put these together, it becomes this graph. Okay? Maybe that's a little bit hard to wrap your head around, so we're going to try it together. So again, X as a function of time, Y as a function of time, because they're both by time, okay? It's moving horizontally and vertically at a certain time, okay? Our function is defined on an interval of I of t values is a parametric curve. The equations are parametric equations for the curve. The variable t is a parameter, and I is a parameter interval. Now, interval means I'm going to give you a certain amount of time, like from 0 to 5 seconds, from maybe 1 second to 10 seconds, you know? In that time, what happened? Okay. Another thing I'm going to mention before we get started is that there's other parameters that we can include, of course, but in this, for our sake, we're only going to probably add the parameter of time t. Okay. All right, first let's talk about sketches. You're going to find this pretty fascinating, I think, okay? It's a little bit different than what you're used to sketching, okay? Is my face in your way of the definition? Sorry about that, okay? Just make sure that you're looking at your own notes too. To sketch a plane is part 1. Example 1.1, sketch the curve given by the parametric equations and describe the orientation. Whoa! Orientation, what the factor is that? Okay, so we're going to do two things. Sketch, and we're going to mark the orientation. Here's what we mean by that, okay? It's super duper easy to do. So we're given X as a function of time, Y as a function of time, right? Okay, it looks like we're given 3 different intervals, okay? So let's try the first one. It means 3 seconds to 1 second. What happened? Which direction was it traveling? And so forth, okay? So what we're gonna do is we're gonna make the most basic thing that you're used to. How do you graph anything that you never know how to graph? Make a table. Let's make a table, okay? I know, it seems so silly. X, oh, just kidding, that's the difference, right? Psych, T, X, Y. Bing, bing, bing. T, X, Y. And we're going to try every integer seconds. So we're going to go -3, -2, -1, 0, 1. That's it, because it says only try from -3 seconds to 1 second. So you know what we're going to do? We're going to draw a table like this. And rather than plugging it into one equation, there's 2 equations. But they're all in terms of t. So we go, hey, when I plug in -3 into t, what do I get for x? When I plug in -3 into my y, what do I get for y? So let's try that. Negative 3 squared minus 2 is, you're right, 7. Now ask your neighbor or call your friend right now. Ask if they understand 7. So you know what? I'll just write a little note here. X equals negative 3 squared minus 2 equals 7. Just to prove a point here. How about y? Y when it's negative 3 is negative 3 times, it's 3 times, I'm going to write it exactly as possible. 3 times negative 3, which is negative 9. Does that make sense? Negative 9. So it's negative 9 here. Okay, so at the negative third second, x is at 7 and y is negative 9. Okay? All right, negative 2. How about negative 2? Let's just plug it in. Okay, I'm not going to show this work anymore. 4 minus 2, which is 2. Right? Let's try the y. Negative 2, right? Negative 6. Are you following okay? Try the next one on your own. Negative 1 squared minus 2 is negative 1. 3 times negative 1 is negative 3. 0 minus 2 is negative 2. 0 times 3 is a 0. And it's 1 squared minus 2 is negative 1. And 1 times 3 is 3. All right, so we have still xy coordinates at this second. So you know what we're going to do? We're going to sketch it. We've done a table. Now we know the values of x and y at t, right? So we're going to actually sketch it. Let's sketch it. Are you ready? All right. You sketch it the same way you know how. 7, negative 9. 7, negative 9. Oh, it's so ugly. Let's count, okay? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going way down. Who cares? Just make it up. Just make it up, okay? So that's negative 9, okay? Okay, so I'm going to write that. 7, negative 9, okay? 7, negative 9. But you know what I'm going to do? Instead of writing 7, negative 9, when did that happen? It happened at t equals negative 3. You have to label when it happened. Let's go to the next one. 2, negative 6. 2, 1, 2, 3, 4, 5, 6, negative 6. When did that happen? T equals negative 2. Oh, if I just had these two dots, I could go either this way or this way. But we know for sure that this happened first. So we know the orientation. Oh, let's keep going. Negative 1, negative 3. Negative 1, 1, 2, 3. When did that happen? T equals negative 1. Negative 2, 0. When did that happen? At t equals 0. When did negative 1, wait a minute. Negative 1, positive 3? It happened here. So it's t equals 1. Dun, dun, dun. So tell me, why don't you sketch? But start from the earliest time. So it's going to go, well, you can sketch whatever direction you want to. However, you know for sure that this path, let's say this is a fly flying in your face. Like a mosquito. Right? Which path is it flying? It's flying. According to this, it's flying. Before, we couldn't tell the path that it was flying. We just saw the general curve. Like, we just knew that they're flying here like this, right? But we didn't know if it was flying this way or flying this way. But now we can tell that it's flying this way. And that's what a parameter does for us. It's kind of fun. I think it's really cool. Okay, go ahead and try the table for these two too, okay? Now, what I'm going to do is I'm going to try one more with you. But all you got to do is actually graph all of them, okay? I mean, graph and label. Graph and label. So let's try that, okay? So what I'm going to do is I have the table. Go ahead and stop the video if you want to. And try for B. And then come back. B is actually from negative 2 to, it's a different time interval, right? So the fly was maybe flying from here to here, negative 3 to 1 second. But how about if it was flying from negative 2 to 3 seconds? Where would it go? So let's try that, okay? So we're going to go stop the video if you want to and try it for yourself, okay? Now that we know how to control the actual table, I'm not going to show much work with that. I'm just going to fill in the values. And you know how we achieve the x and y. So I'm going to just write the values. Are you ready? I got 2, -6, -1, -3, -2, 0. You're right. These are all the values that are the same. How about 2? It's 2 and 6, 7 and 9. Those are the new values, right? New values, okay? But A and B are not the same. Because look, this fly, it only was able to fly from here to here, and then you killed it. Okay? You understand that? So now let's try B. -2. I'm going to try it with the yellow marker. Or orange, okay? Oh, no, it's a red, so I'm going to go maybe purple. So you ready? -2. It's this, right? I'm just going to kind of go over it, okay? -2. Okay? T equals -1. At different times, it was at different positions. You understand what I'm saying? T equals 0, right? And then T equals 1. At 1, it's -1, 0. But how about 2 and 6? 1, 2, 3, 4, 5, 6 here at T equals 2. 7, 9. Oh, sorry. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right here at T equals 3. Now, let me ask you this. Is this second fly flying at a same orientation? Yes, okay? So you can be sure of that, okay? So you're right. This one goes from the purple. Let's go to the purple. Purple goes from ding, 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 ding. I'm just going to go on the outside of it. And it's flying this way as well, okay? But just so you know, okay? Just so you know. Wait, no, wait. I forgot something. It didn't actually fly from 3 seconds though. It only started from 2. So you don't have this part here. It actually only goes from here. So you see, if I asked you, what's the difference between fly A and fly B? You would say, well, fly B flew a little bit longer time. It took a little bit longer for it to die because it flew for 2 more seconds, right? Was it the same path? Well, pretty much the same path. I think if fly A lasted longer, then they would have been on the same path, okay? Now, see what happens when you actually graph. Let's go C. Okay, C, I have the table for you from, it's actually just adding 1 more second to the end. So C would just be the whole thing, okay? All right, so who flew the longest? Were they all flying in the right path, in the same path? They were all following the same path, okay? Those are the kind of questions I could ask you, okay? Okay, well, I'm going to show you something real quick, and then I'll stop, and then we'll pick up when you get back to class. Now, I see this rectangular equation here. You know what a rectangular is? It's when it's not parametric. Wait, but let's recap. Do you understand how to graph a parametric curve? Do you understand orientation? Okay, orientation is just marking the direction that it's flying. Which direction is it flying? You're right. Is the arrow absolutely necessary? I like it because it's the visual. But if you actually label each time, which you're supposed to, it kind of tells you the orientation as well. Okay? All right. Now look at this rectangular equation that's not a parametric. It's not parametric because it tells you x and y. And it's a curve because this is a quadratic. Now, we can even find out more information about this rectangular equation by using parametric equations. Because look what I did. This is just demonstrating what I actually started the notes with. Time and the horizontal. All the x values that are here, I marked it here on the y-axis with time. Same with vertical. I said, hey, all these y values here, I'm going to mark it with over time. But what I'm used to doing is just the horizontal versus the vertical. But when I put the horizontal and vertical with parametric, the time together, then I get this beautiful thing, which is like orientation and time. Tells me which path that it's following. That's the power of parametric equations. I may ask you that on the test, on the CR section. Why is parametric equation better than a rectangular equation? What are the benefits of a parametric equation versus a rectangular equation? Right? Which graph do we see more information on? Okay. See, ask yourself if you really truly understand what parametric equations are doing and what the curve is showing, okay? All right. And then I think we could pick up and be able to finish everything that we need to finish in class, okay? All right. Bye. I may put up another video. Watch out.